All righty, so while everyone's still coming in, I will go ahead and get us started. So my name is Jasmine Lathan Gordon. I am the AAS Meetings Coordinator. As a reminder, this session is being recorded. You'll be able to access it within 24 hours on the BFairs platform. We will have time for questions and answers around the 15-minute mark. So that'll be at 12:15. You'll be able to unmute yourself or put your questions in the chat box here on Zoom. We do have a hard stop at 12:30 because we have another webinar right after this one. And with that, I introduce our speaker for this evening. We have Dr. Margaret Metzner from SOFIA.
Hello, everyone. Thanks for coming to hear about science from the stratosphere, what's new with SOFIA. I am going to turn off my camera because my internet is rather low, and I'd rather have you hear my voice and see the slides, and I'll open it again. All right, so what is new with SOFIA? So the science of SOFIA touches all of NASA. In Earth science, SOFIA's archival data has been used to directly measure atomic oxygen in the mesosphere and lower thermosphere. For planetary science, it has been used to measure water on the sunlit surface of the moon. SOFIA has been primarily used for astrophysics and has learned how magnetic collapse occurs in the star formation process. And finally, SOFIA scientists have adopted techniques from heliophysics to derive parameters of magnetic fields in a starburst galaxy. These recent results show that SOFIA's wavelength range is the most untapped in astronomy, enabling astronomical discovery. Let's see some of those discoveries that were published in the first half of 2021. I hope you all got to see Enrique Lopez Rodriguez's spectacular Kavli plenary lecture on Monday morning about magnetic fields and galaxies. His recently published result on the magnetic field in Centaurus A addresses the question, what is the effects of mergers on magnetic fields? Polarimetric observations from the GalMag Fields Legacy program that he's leading show the magnetic field globally aligned with the disk, but with significant dispersion of orientation at small scales. Small scale turbulence must be distorting and enhancing the original large scale magnetic field. Using 2 epoch measurements, SOFIA has detected the accretion events in massive young stellar objects. So methanol maser flares are signposts of accretion bursts in massive YSOs. What causes these bursts? Only far infrared can access the total mass accreted during a burst by probing deep in the YSO's envelope. Thanks to the flexibility of DDT proposals, SOFIA observed YSO 358 after a burst. Data suggests accretion occurs through a transient and clumpy disk, confirming that the accretion process for high mass stars and low mass stars is similar. The SOFIA Great instrument has measured 13 CH in the interstellar medium. Why is this important? Chemical evolution models predict that 12C to 13C should increase with galactic radial distance, but detecting optically thin tracers is a challenge. So the Great instrument, confirming its status of astrochemistry asset, was able to detect for the first time 13CH, an optically thin transition towards 4 high-mass galactic star-forming regions. A revised, steeper galactic gradient was determined, providing new constraints on chemical evolution models. In addition to numerous striking scientific discoveries, SOFIA and its community have worked hard this year in planning for the future capabilities of the observatory. This notional timeline shows the 10-year horizon for SOFIA's instrument suite, and there are 3 steps. The first step has already started. Our HawK Plus instrument, which has been used to make these magnetic fields measurement, will be getting a replacement of detectors and increase of array size expected to be completed by 2023. This will enable mapping of magnetic field speed up to 4 times faster. Step 2 involves a new instrument to be determined. It will be science-driven, and there are 2 options that were put forward. One is a direct detection spectrometer, and one is a heterodyne array mapper. And then the third step, which is far in the future, will be revisited with the community as to what would be the most scientifically compelling instrument to pursue at that time. Now, all this is documented and described in a publicly available instrument roadmap. This has been released. The report's available at this HTTP URL. And the roadmap is focused on a prioritized science cases and technology needed to enable them. I encourage you to download and read it. And of course, the SOFIA team has continued to operate the observatory with the objective to maximize observations in Cycle 8. So Cycle 8 will end on July 2nd. As we know, with the COVID pandemic, observations were suspended temporarily between March 18th and August 17th, 2020. But our team has creatively adapted the flight schedule to return to flight and then to pull off what can be not overstated as a very heroic effort to go to Germany, have a German-based deployment in February to March 2021, and pull off some amazing observations, including observations of several legacy programs. This was really heroic because they did this in the middle of this global pandemic safely, and everyone, it was just a really uplifting experience for the whole project. So we have a lot of great science to look forward to in Cycle 9, which begins in July. There were 121 proposals selected. It was highly competitive for the observing time with an oversubscription rate over 4. Over 195 science flights were planned for a total of 820 observing hours. This is an increase in research hours, 25% to prior cycles. We've also been increasing the observing time in the Southern Hemisphere. There are 3 planned Southern deployments, including one that's up and coming in July to September 2021, which will feature the HawK Plus and GREAT instruments. So approximately 1/3 of the Cycle 9 time is devoted to legacy or pilot legacy programs. In Cycle 9, we hope to finish the feedback legacy program. This program features the GREAT maps of C2 and O1 in star-forming regions, such as the Eagle Nebula or M16 shown on the right. These are, what we're seeing here is a transition from the famous Hubble image showing these pillars likes of creation, transitioning into the GREAT map. And the colors you're seeing in the GREAT map are different velocity structures that show the motions of the interstellar medium that are measuring the feedback in the star formation process. As with all legacy programs, this projects in progress, and the preliminary maps are already available in the SOFIA archive for anyone to use. The HighGOW Legacy Program, led by Dave Neufeld, is characterizing the galactic interstellar medium with hydrides and took its first data during SOFIA's deployment in Germany a few months ago. It uses the absorption line spectroscopy of many hydride molecules to extract astrochemical models of the turbulent interstellar medium. So this is a fascinating program with chemistry, but also measuring these very hard to understand processes of turbulence. And we are returning to the moon. So the moon observation was a single pointing, the one that's been heard about. And the PI, Paul Lucy, is put in for a full legacy program, and we're doing a pilot this month from Palmdale. This is a follow-up of discovery of water on the sunlit surface of the moon, and the plan is to pursue large-scale maps to study the distribution of water across the lunar surface. Now, HAWK Plus polarimetric study of the Serpent South clouds shows that gravitational collapse can occur even in the presence of relatively strong magnetic fields. And the person who led this amazing discovery paper, Thushara Pillai, is now leading a legacy program to measure incidence of the magnetic field and filaments in nearby filaments. And this is a legacy program called Simplify, Study of Interstellar Magnetic Polarization, a Legacy of Filaments. There is a pilot coming up in this 1 year, and that should be released within a year from now. And we have, can you all still hear me?
Yes, we can hear you.
Okay, it said my internet was unstable. So SOFIA HAWK, filaments, extremely long and dark, of magnetic polarization. So this is field maps. The PI Even Stevens has, this program's been started. The pilot's been completed. And what you're seeing here is this filament, these very highly dense filaments, showing the percent polarization occurring around the filament. And they are in the process of analyzing this. And our process for legacies is a pilot has to be done. They have to demonstrate how viable it is and that there's going to be a big impact from it. And that's the process that he's going through right now. Right. Now, SOFIA HAWK Plus is also looking at the galactic magnetic fields at the center. This is led by Dave Schuch. This is a pilot that's up and coming in Cycle 9. And the plan is to map the magnetic fields in the central 200 parsecs of the Milky Way with the HAWK Plus instrument. And that's the region you see here. What's shown here is a speculation of what those intensities of the polarizations may be to demonstrate the validity of the project. And outlined here in blue is our first legacy program, which is the map regions with forecast to study the star formation in the galactic center. And so the magnetic fields, it's going to add a much needed piece to understand the fascinating environment that the galactic center has for star formation. Now, Cycle 9 also marks the start of observing partnerships with other facilities. So here we're showing a slide with partnerships that we have with the James Webb Space Telescope, the Green Bank Telescope, and with the Hubble Space Telescope. We have 3 programs supporting James Webb early release science and guaranteed time observations in Cycle 9. And we have 3 programs that are joint with the Green Bank Observatory. We have 2 DDT programs that we are exploring with the Hubble Space Telescope, and the observations for one of them, for SOFIA, were carried out during the German deployment. So we're well on our way to these large observatory partnerships with SOFIA. Now, the observing program for Cycle 9 is mostly set, but there are still many opportunities to get new observations approved. So observationally, DDT programs, that is the Director's Discretionary Time programs, are open year-long, and we've started a new process with a dedicated TAC all the time, and we aim to have a 1-week turnaround on decisions for these. Here's the link to learn about this. We recently tested this out with a flash call that we had with Forecast in May 2021. So flash calls are another way that we will advertise saying we need your programs. And then in Cycle 10, there'll be the call for proposals that will open in the fall 2021. Now, I also encourage you to look at the archive. We have a very rich archive in URSA, including data from many legacy programs. Follow the link here. And our instrument scientists have an expanded series of curated archival data sets. That is, archival data sets they've identified that are very high quality, that have yet to be published, and are looking for some curious astronomer to come along and tell us what it all means. Archival funding proposal calls are also part of our opportunities. We have annual, separate from the observing call. Following the success of our last archival funding call, we had 11 programs selected out of 42 submitted for a total of $1.8 million of support for archival research with SOFIA. And I know you all want to show off your great SOFIA results. We have a number of upcoming community events in which you can describe and articulate these results. We have a SOFIA Alma Summer Series going on starting this Thursday, June 10th, and going through July 22nd. It's online. We have a Magnetic Fields and the Structure of the Filamentary Interstellar Medium workshop. That's a virtual workshop from June 22nd to 25th. That's online. You can follow this link. It's free registration. Come and listen or come and show off what you're learning about. The Future of Airborne Infrared Submillimeter Astronomy, Prospects and Opportunities is an online workshop hosted by our German partners on SOFIA. It will be July 26th through 28th. It is online, and it is a workshop in which our German partners are trying to suss out their future vision for instrumentation in this field, and along with opportunities with SOFIA. So if you are interested in the future of SOFIA instrumentation or just the science with SOFIA, I encourage you to come to that workshop. And finally, we will, looking forward to post-pandemic when we can actually meet face-to-face, we are going to have a face-to-face conference on galactic ecosystems, far infrared diagnostics, and opportunities. We have tentative dates of February 28th through March 4th, and we encourage you to visit this website for more details on these events. And finally, please join the SOFIA community. Call in to our online SOFIA Alma Summer Series, and we have a teletalk series to check out the latest results. Keep informed about news and opportunities with our monthly e-newsletter. Have a look at the archival data at URSA. Easy visualization directly through the URSA online platform. Send us an email for any questions or guidance at sophia_help@sophiausra.edu. If you have a cool idea, send us a proposal for DDT, or wait for Cycle 10. And hey, join our team. We have several open positions at the Science Operations and Community Engagement teams. Visit the SOFIA exhibit booth for more information and to chat with staff. And I'll end there, and thank you very much for your attention.
Thank you so much for your presentation. If anyone has any questions, go ahead and unmute yourself or put them in the chat box. I did see we have 2 questions from Bob, so let me read the first one first. How are instruments selected for availability in cycles?
Oh, that's a very good question, Bob. So how are instruments selected for availability? There are a couple of things. One is that for a call, all instruments are available. However, for southern deployments, we have, starting in cycle 9 and likely in future cycles, we will select which instrument will go on these southern deployments, so people have a clear idea of what those opportunities will be. From the northern cycle, we basically any instrument is available. So anyone can propose for these instruments, but during the selection process, we do look at the schedulability of things. We can only put one instrument on at a time, and switching the instruments, and campaigns are typically at least 2 weeks long. So in the post-selection process, there's a scheduling aspect that folds into the selection of a program. But if you have a really good science idea, I encourage you to apply for that. In the Northern Hemisphere, like I said, every instrument is available. And in the Southern Hemisphere, we are likely to just sort of pick to let people know which of those opportunities will happen.
Excellent. He put a follow-up question, but I think you may have answered it. Are all instruments available for access to the community?
Yes, all instruments can be used by the community. So we have, just to go through them, we have, forecasts, which is our mid-infrared, but also has a GRISM spectroscopy. Emily Levesque showed a GRISM spectrum of a red supergiant on Monday afternoon in her Pierce Prize lecture. We have XEs, which is high spectral resolution mid-infrared, higher than, for example, will be possible with instruments like James Webb. It goes to 10,000, R of 10,000. We have the Hawk Plus instrument, which is photometry and magnetic fields in the far infrared. And there's PHLS, which is spectral mapping in the far infrared, but low resolution, so ideal for extragalactic. And then there is the GREAT instrument. That is a PI instrument, but it is made available to the astronomy community through memoranda of understanding, and it provides the same type of spectral resolution capability as ALMA. But yes, all of these are available to members, anyone who wants to propose.
Excellent. We have a question from Jeff. Is the uncertainty about FY22 appropriations for SOFIA affecting planning for future observing cycles or other aspects of SOFIA operations?
The answer to that is no. We are fully funded, as we know, for FY21. And we've been in this place before where, the president doesn't have us in the budget, but we've enjoyed strong congressional support, and we are planning for success and anticipate that success to be realized. We will have, so the cycle 10 call will be going out in the fall, and expect to bring your great ideas to us.
All right, we have a question from William. So what mid and far infrared spectroscopy is available for astrochemistry?
So astrochemistry, so mid and far infrared spectroscopy. So mid infrared spectroscopy, astrochemistry wise, a lot of people like to use the XEs instrument if you're looking at molecular species, because you get that resolution to delineate all those spectral lines. So XE is great if you want to look at molecules. If you're looking at dust sort of dust mineralogy sorts of things, forecast, or XEs could be good for that. But going out to the far infrared when you want to look for molecular species, a lot of people like to use the GREAT instrument, again, because you have that high spectral resolution where you can separate and measure those different molecular species. That's why Neufeld is using GREAT for his HighGOW measurements. And yeah, I would say that those, if I had to think of just astrochemistry, I would probably think of XEs and GREAT.
All righty, we have time for one final question. We have a question from Sean. You mentioned something about forecasts and flash proposals. What does that entail, and how often are they announced?
Right. So we had a flash call because when we created our schedule, this has to do with the moon. The moon, we realized that we can't use the short wavelength channel. And so originally we thought, we would have a dead leg, but we realized we could use the long wavelength channel. And we had no programs in our archive that used the long wavelength channel of forecast in that time period. And so we announced a flash call, and it was very quick turnaround. I encourage you to be on the SOFIA email distribution list to learn about these opportunities. But we told the community saying, hey, if you have an idea on what to do, and we told them these are types of objects that would be visible to you, send us your idea. How often do they happen? Maybe once a year, once every so often. We try to have programs in our stall to actually address this, but we do come up with opportunities where we have to point to a certain direction on the sky because of the flight plan, and we don't have objects in our database to cover that. But I do want to point out, if you have an idea, that the DDT program, if you look on our site, we do solicit that if you have an idea for like an hour or two that you want to test out something, or if you want to, let's say you're a student and you're trying to finish your thesis and you need that one last hour or two of SOFIA time, I encourage you to use the DDT cycle, proposal cycle, as a means to request some time.
Alrighty, that's all the time we have for this evening. I want to thank you so much, Dr. Margaret. You did such a well presentation, and also want to thank Leslie, who has been putting links in the chat box that are easy for access. So thank you both, and I hope everyone has a great rest of your afternoon or morning.
Thank you all. Hope to see you on a flight sometime. Bye.